Everyone is asking, will AI take my job? But that's the wrong question. The real question is, which careers will still need humans even when AI becomes insanely powerful? Because, yes, some jobs are already disappearing, but some careers they are much harder to replace. And today we are going to break them down. Also, I'll tell you how I came to this conclusion because some roles are not as safe as they look. Okay, most people think AI replaces jobs. It doesn't. AI replaces tasks inside the jobs. Okay, so complete profile that a person was doing is not getting replaced, but certain tasks that he used to do in a repetitive way. Okay, so in coding, if you think of it like a boilerplate code that needs to be written like CRUD jobs, so those will be replaced. Okay, so the real work or the real logical part of the task doesn't really get replaced because that is the novelty part. Okay, so that kind of part is hardest to automate. So the safest careers usually have these following four traits. First one is they deal with the real physical world. Secondly, they involve high responsibility. Thirdly, they include messy, unpredictable problems. And finally, they require debugging when nothing makes sense. Let's apply this. Low level programmers. Yes, this is a relatively safe field, but not because of coding, because of systems thinking. AI can write C++ to a good extent, but it struggles with things like race conditions, memory bugs, performance bottlenecks. So, what actually survives is kernel development, performance engineering, debugging real systems under load. So, don't just aim to write code once, aim to understand how systems behave. So, don't just simply copy the AI slop, but rather try to understand the rationale behind the code that AI is even generating if you are using AI. Then embedded engineers, this is one of the strongest fields because you're working with hardware constraints, timing guarantees, real world signal analysis. So AI can generate code for this context, but it cannot debug a board when the timing is off by a certain milliseconds or you have missed a certain instruction. So why that thing is happening, you are not able to read from a sensor. So these kind of things is the core engineering of this part. Analog engineers, honestly, this is one of the safest fields in the AI world. Okay, because the real world is too messy. So whatever signal that is being captured in analog form contains a lot of noise, parasitics, temperature effects, things that don't behave perfectly in most cases. Okay, so AI works best in clean, predictable environments. Analog is totally a 180 degree of that. Okay, so it's totally opposite. So that is why analog engineers will be in high demand even during the age of AI, and this will probably never change. Power and distribution engineers, this is a very critical infrastructure. Electric grids do not tolerate mistakes. The cost of failure is massive. AI currently is involved to some extent in analytics and in some parts in like the outage management system, so that sort of a thing, like all the analytics part. But apart from that, a lot of humans are responsible over here. Okay, and a lot of software that is used has a lot of safety features. Okay, so these safety features are truly hard coded and the paths are manually checked. Okay, so that is why this field also will very likely be affected by the AI invasion or whatever you call it. Okay, and also AI itself needs a lot of power, so new power grids are also being set up. So if you might have seen the news, you might know that Google and all this OpenAI and all these guys are trying to build power station as well. So power will be the next, what do you call, electricity will be the bottleneck. So obviously a lot of jobs in this sector as well. Apart from the software related jobs, you will have like hardbound jobs also in the power and distribution sector. Networking. So most people think networking in a very abstract way. Okay, so traditional networking roles like configuring routers, managing networks are getting automated with cloud platforms, and then things like software defined networking. A lot of this is already abstracted anyway. But what survives is the ability to design large scale distributed systems, handling failures across different places like data centers and all these places. Then performance tuning under real traffic. So like how do like scalable systems handle a million users in streaming platforms, or like any kind of HFLP platforms or anything likewise. Then finally it is about building resilient fault tolerant architectures. So anything and everything that you read in Martin Kleppmann's books. So that is why this field is also rigid. Okay, so it is safe by default, but only for complex system level parts. Okay, control systems. So control systems engineering is quite huge and totally underrated. Robotics, aerospace, autonomous systems, you name it. You are dealing with feedback loops, stability, real time correction, lot of maths, physics, and real world behavior. So this field usually works in conjunction with the analog design engineers and stuff. And this is very hard to automate fully. This is truly something that AI would probably not be able to do for a very, very long time. So this field is also really bulletproof. Cybersecurity. Cybersecurity, but the real cybersecurity, not just running script tools or like any kind of tools like Metasploit or stuff, but deep understanding of systems to break them and defend them. AI helps attackers too. So this becomes kind of an arms race, you could say, and humans stay critical because this thing keeps on evolving. Now with introduction of this AI itself, the kind of bugs and stuff or attacks that are happening on systems have also increased to a great extent. So this field truly remains critical and something that you could hope for in the long term. AI engineers. Ironically, the people building AI are amongst the safest from the AI. So there's a lot of model optimization, infra development, and deployment of these models that is going to be done over the years. So anytime soon they will not be replaced. Okay, so there are like newer opportunities like ML ops, AI ops, and a lot of things which are like low entry barrier as compared to what you call like the proper AI engineers or like AI research scientists that you might be thinking. So these kind of careers also are going to exist apart from the DevOps that exists today. So this is one career that is AI proof. Hardware engineers, chip designers, ASICs designers, verification. Okay, so these kind of careers which are having like extremely high barrier. Okay, so these kind of careers are almost irreplaceable with AI. So this career also is an option for people wanting to get into an AI proof career. Okay, so speaking of what you call the high barrier part, so there are cases where people have transitioned into hardware engineering even from software background. So slowly people started learning about embedded systems, then slowly they learned a CAD software or two, then they went into like Verilog or VHDL, that sort of a thing, and then slowly they have transitioned into a hardware engineer role. So there are many cases as such. So if people want to transition from software, or even people who are like actually into like hardware related stuff, can try their hand at it. So though like I said, the barrier is high. It's not like you cannot get into the industry. It's a very small industry, not a lot of competition, I would say, but it is a very extremely challenging role. So here's the truth: no career is AI proof. AI will eventually enter every other field in some way or the other, but it will not totally replace you. So there are two things. In some fields, it might replace you, in others, it becomes your tool. So don't chase safe careers, chase the hard problems, because AI is currently replacing people who lack problem solving skills, but it cannot replace people who understand the systems and know how to solve the difficult problems. Thank you.